can have wireless mesh networks, wireless sensor networks, mobile ad hoc networks, and other types of ad hoc networks as well. So I'm going to go through quickly go through them quickly to explain what they are, right? So mesh networks. So you can imagine, let's say after an earthquake, the base stations are down, right? Now, we need to have a temporary network in order to connect the first responders, for example, to connect the rescue workers, for example. How do we do it? We can deploy wireless routers. So you can see these are wireless routers. So you can have these wireless router, for example, on a truck, on a crane, right? You can have a crane, a truck with a crane on, and then you put this wireless router on top. And then around these routers, you can have other trucks that carry other access point as well, routers as well. And they form a mesh so that if you have devices from the first responder, from the rescue workers, they can talk to this wireless router, for example, on this side. And then the message here will be relayed to this router, to the internet, for example. And similarly, if someone here requests something from the internet, it can be sent to this router, to this, and this, and this, to this. So these links here, you can see these dotted lines, they are wireless links. They are wireless links. All right. Now, the question is, why can't they, there's a question on the chat window, why can't they request directly to the internet? Because remember, the wireless, your wireless transmitter, it has a very short range, right? If you are very far away from the gateway, the internet gateway, you cannot, the transmitter cannot reach that gateway. It has to go through several hops like this, you know, to get to the gateway. Okay, so something when we learn about wireless networking, something you have to keep in mind. The range of wireless transmission has a limit. It's not limitless. All right, it has a limit. And the limit of the wireless transmission range depends on the technology. We'll learn about this later, about each technology. It has a different range, right? But the reason it cannot reach the internet directly because it's far away from this internet gateway. Okay, so it has to rely on these to relay the message or to relay the request to send to the internet. Okay, so this is called wireless mesh networks in the sense that you deploy or we deploy a set of access points or wireless routers, and they form a mesh, and this mesh is responsible for relaying messages from the devices to the internet, or the other way around, from the internet to the devices. Okay. All right, any questions? Okay, and these are wireless routers or access points. So they have higher transmission range, they have higher capability than, let's say, the devices. Let's say if you have a mobile phone, right? Okay, so that's one type of infrastructureless network. So there are many applications for mesh networks. We can use it in home networking, community, enterprise, metropolitan area network, transportation system, building automation system, health and medical system, security surveillance system. So basically, if we can get a set of access points and then we configure them so they can talk to each other to form a mesh like this, then we can have a kind of a mesh network. Okay. All right, so next is wireless sensor networks. All right, so this is one example of a wireless sensor networks. We use sensors to monitor the condition of a forest. right? So each circle represents the transmission range of a sensor. So for example, we have a sensor here. We have a sensor here. And this circle represents the transmission range of this sensors. And we have many sensors like that in the forest. So they can be used to measure, let's say, the temperature, the humidity, for example. So that if, let's say, there's a fire, the temperature would be high, then the data will be collected by this node. This is called a sink. So the sink in a sensor network, this is called a sink. The goal, the objective of a sink is to collect data from neighbors' sensors. So every sensor will send the data to this sink, and the sink then relay the data back to a control center. So the control center is the house here at the bottom right corner. Again, we have another sink here, and the sensor around this sink will send data to the sink, and then the sink will relay data to the house at the right corner, bottom right corner, right? This is the control center. So wireless sensor networks, this kind of wireless sensor network is used to monitor a forest for humidity, for temperature, for example. So another application is, let's say this is for monitoring a military base, right? So you can see in this military base, you can deploy video camera. So these are video camera, infrared camera, for example, microphone as well, microphone. And the information will be relayed from one to another. Let's say from a sink to a control center. Let's say this is a sink to a control center, and assume there's a fire here, for example. Then the camera may detect the fire and send information to the drones here, up here, so that the drone can communicate the condition of the fire to the command center. Right? So this is another application of using sensor networks. And sensor networks have been used in many applications, let's say for tracking wildlife animals, right? So if you watch National Geographic, you see that many animals have sensor attached to them for conservation efforts, right? We can use sensor networks in order to survey dangerous terrains, so people cannot go into those areas. So you can attach sensor to robots, and they can go in there to detect fire, radioactive material, for example. It can be used, sensor network can be used for machine surveillance and preventive maintenance as well, where you cannot run cable or wires. And it can be used in medicine and healthcare. And I'm pretty sure that you've seen sensor attached to patients in order to monitor their heart rate and motion, for example, and send to a control center, right? All right, so now another type of infrastructureless networks is mobile ad hoc networks, or MANETs. So this type of networks were first created for military applications. So that's why we can see, we usually see when we talk about MANETs, we see a military example. So in this case, the source and the destination are far away from each other. For example, these soldiers want to talk to this tank, for example. There's no direct communication lines. Again, the reason is that wireless devices have limited transmission range. If they are too far away from each other, they cannot talk to each other. So in this case, each device in the network will act as a router to relay the message to the destination. So assume these soldiers want to send a message to this tank. It will send to this satellite, for example, a small satellite here. This will relay the message to this tank, this will relate to this tank, and this will relate to this tank to reach the destination. Similar in this example on the left, we have a laptop that wants to send a message to a cell phone destination. Again, you can see the transmission range here is this, which is the red line, which is the red line here. They cannot talk to each other directly because they are far away from each other. So the laptop will have to ask other devices in the network to relay the message to this cell phone. So it can go through this cell phone to this laptop, to this phone, and to this phone, or it can go this way, depending on which links are available. Right? Okay, so any questions so far? So we can see here that we don't have any infrastructure built in advance. So we have to rely on other devices in the network to relay the messages for us from a source to a destination, right? So yeah, again, so this is what I've just said before. There's no infrastructure. A node can act as a router, and they have to communicate using single or multi-hop wireless links, okay? And again, in this kind of network, it's very difficult to design protocols because the topology changes over time, the location change over time, the connectivity changes over time, the transmission quality changes over time as well, because nodes are moving, they are on the move. You don't have a fixed network topology. You don't have a fixed set of connectivities. The transmission quality are not fixed either, because devices move from one location to another. Okay, so MANETs have been used in military applications. So basically, they were first created for military applications, for battlefield communication, monitoring, and planning in the battlefields. But they can have many civil applications as well. For example, for disaster recovery, similar to the example I mentioned earlier about wireless mesh networks. After, let's say, a flood, an earthquake, if the base stations are destroyed, a set of devices can form a small wireless ad hoc network to talk to each other. They can be used in taxi cabs at airports, for example. Communication over water using flows or vehicular ad hoc networks. So we'll see some of these later. Okay. All right. Any questions so far? Okay. So now in this course, of course, we don't have time to cover everything. Like each of these boxes, let's say cellular networks itself can require 1 or 2 courses. Wireless local area network itself, 1 course. Mobile ad hoc networks, again, itself 1 course as well. Sensor network, 1 course. We don't have time to cover everything. So we just cover very basic information, wireless local area networks, cellular networks, because you use these every day. And then another type of infrastructureless network, so that you have ideas about how they can be built and be operated. So we will cover mobile ad hoc networks. We will not have time to cover mesh networks or sensor networks. Now, there are other types of ad hoc networks as well. And I will go over them quickly, so you know that they exist. But again, we will not have time to go into detail to discuss these networks, right? Okay, so other types of ad hoc networks. Now, the term ad hoc here implies that you build things on the fly, right? You build things on the fly, so the term ad hoc. So we have vehicular ad hoc networks, flying ad hoc networks, and underwater vehicular ad hoc networks, right? Now, from the name vehicular, what can you imply from the term vehicular? What will you see in here? if you hear the term vehicular, what kind of device, what kind of that you think you will see? Anyone? Moving devices, right? Moving devices on cars or trucks, right? On cars or trucks, and that's basically vehicular ad hoc networks are for cars. And then you have flying ad hoc networks. Again, you have to use drone, right? Or we call UAV as well, unmanned aerial vehicles, drones. And then you can have underwater vehicular ad hoc networks. That means moving devices underwater. Okay. So this is an example of a vehicular ad hoc network. So basically, each car would have a mobile device and they talk to each other. And if they talk to each other, it's called vehicle to vehicle. Okay. And then some cars can have connection when they come close to a base station or an access point, then they can connect to the internet. So we have V2I, mean vehicle to internet. So in that sense, they can connect to the internet. So if a car is far away from an access point, then they can ask another car to relay the information for them, right? So this car can send a message to this car, and this car would send it to the internet, right? Similarly, this car can send it to this one, and then the blue car sent to the red car sent to the black, and then sent to the internet, all right? Someone asked a question about Starlink. I think Starlink is satellite network. So that means the car talks to the satellite network, not directly to each other. Okay. So you can see that designing protocols for vehicular networks are very difficult because cars are moving fast, right? You send a message to this car, and maybe in the next few seconds, it will be moved out of the range of this access point. And then what does it do next, right? It has to find another car to relay the message. So this kind of vehicular networks is difficult to design protocol as well because cars are moving fast. And then next is flying ad hoc networks, so drones. Okay, and one application of drones is, in this case, is traffic monitoring. So basically, the drone will monitor the traffic, and if it sees like high density on a highway, it can assume that there's a traffic jam, right? So in that case, assume that this drone can detect high density of cars. Let's say it has a video camera there, and it can assume that there's a traffic jam there. Then it should send information to, let's say, this drone, and this drone will send it to this ground station. And the information will be sent to a control center or a network operation center. And then this information will be made available to mobile users subscribing to this kind of service. So you know that there is currently a traffic jam on Highway 401, for example, right? And you can see here the drones, they communicate with each other to relay messages, right? And only at the last step that the information is sent to a ground station or the internet, so that the information can be sent to subscribers. Okay, so this is one application of drones or flying ad hoc networks. And this is another type of ad hoc network, which is underwater vehicular ad hoc networks. So you can see these fish, they're not sharks. They are some kind of vehicular devices, some kind of devices underwater that makes them look like a shark, but they're not. And again, they talk to each other. They form an ad hoc network. So you can imagine this as a MANET, a mobile ad hoc network, that in the sense that they talk to each other. And then there will be a gateway here. So whichever device is closest to the gateway will relate the message to the gateway, and the gateway will relate the message to either satellite or other kind of communication means, so that to get to the internet, for example. And then the other way around, if information from the internet is transmitted from the satellite to the gateway, and from the gateway to a destination, one of these devices, all right? So again, with ad hoc networks, the principle is the devices work with each other to relay the messages from one node to another, either from one node to another or from one device to a gateway, and the gateway will transfer to the internet, or the other way around, information from the internet to the gateway, and the gateway will send the data or the message to a device. Okay. All right. Okay, so any question about these kind of networks? All right, so now for the content of this course, we'll have, I think of it as 3 major components. The first one is about the review of previous information. The second part is some wireless communications principles. And then the last part, this is the largest part of the course, which is mobile network architectures and protocols. All right. So to review, we will review signals. So I think you learned about this in 3213. TCP/IP protocol suite, internet routing, Ethernet medium access control, and transport control protocol, TCP. All right. Okay, so now just a very quick survey. I guess you must have learned TCP/IP protocol stack or TCP/IP protocol suite. Now, who did not learn this? Can you please either raise your hand, or maybe raise your hand if you did not learn this. Right? Anyone who did not learn the TCP/IP protocol suite? Please raise your hand. Okay, I don't see any hand. If you cannot raise your hand, you don't know how to do it, you can type in the chat window as well. Okay, so everyone knows. Okay, so that's good. Okay, next item, internet routing. So, who did not learn, I don't need you to know detail or in depth, but just the basic information about internet routing, for example, OSPF routing protocol and border gateway protocol. Anyone who did not learn internet routing, please raise your hand. Okay, 1, 2, all right, let me take notes. Okay, let me count. Internet routing, okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, 8. 8, all right. Anyone who did not learn internet routing? 8, 9. Okay, 10. So if I say OSPF, open shortest path first, and if I say border gateway protocol and you don't know what they mean, that means you did not learn internet routing. Okay. 10, okay. All right, so I have about 10 to 11 people did not learn internet routing. Okay. Okay, all right, next. Okay, so please remove your hand so I can ask the next question. Okay, all right, next, Ethernet medium access control, CSMA-CD. Who did not learn this in your previous network course? Please raise your hand. 8 people, 9, 10, 11, 12, 11, 12, okay. Again, CSMACD, all right, 12 people, okay. All right, so yeah, please remove your hand, lower your hand so we can go to the next one. Okay, transport control protocol, TCP. Who did not learn this in your previous in network courses? 2, okay, 3, 4, 5, 6, 5, 6, okay, all right, 6 TCP, okay, all right, thank you. So okay, right, so now I have to find a way for the student who raised their hand to catch up with these topics, right? Because we need these in the course. Okay. All right, thank you. Okay, so now, so that's the review part. Okay. And then the second component is about wireless communication. So we learn about signal propagation, modulation techniques, and spectrum. So these, so again, I will keep this simple because this usually involves a lot of math. But again, we don't have a big blackboard to go over math formulas online. So I'll keep this the math to a minimum. And then the last part is about mobile network architectures and protocol. And as I said before, we may not have time to cover all types of mobile networks. So we'll cover only wireless local area networks and cellular networks because we've seen this every day. And then for ad hoc networks, we cover MANETs. MANETs will have to give you some basic background or foundation so you can learn VANETs, vehicular ad hoc networks, flying ad hoc networks, or underwater ad hoc networks later yourself, right? But so we'll learn MANETs only in this course. Okay, so we'll cover wireless local area networks, cellular networks, and mobile ad hoc networks in this course. Okay, all right. Okay, so this is the homework for you to read the course information and read the following section in the textbook, Mobile Communications by Schuler Application and a Short History of Wireless Communications. Okay, all right, so now I posted the slides of, let me get the, sorry. Oh, just one more question. TCP IP protocol stack. Okay, let me show the screen. Just 1 second, sorry. Okay, so this is the TCP IP protocol stack. Now, please raise your hand if you did not learn the TCP IP protocol stack before in your previous networking courses. Okay. If you did not learn the TCP IP protocol stack, all right, so it's good. That means everyone, okay, that's good. Yeah, all right. So that's why this will be a review for you. And I posted the slides on eClass. So please go through. Yeah, I see. So in 3213 only the focus only the lower 3 layers. That's true. That means physical network access and internet. Yeah, but that's interesting because with the 3, if you can see on the screen here, the internet and network access, the internet layer would cover internet routing, and the network access could have covered Ethernet, CSMA, CD. But somehow many students did not learn internet routing and did not learn Ethernet medium access control in their previous course. Okay, so we have to have a review. Yeah. Okay. All right. So it's good that everyone knows the TCP/IP protocol suite. So I would recommend you to go over e-class. I'll show you where it's posted. Let's stop share. Okay, so the slides for the TCP/IP protocol suite is here. So please review them. All right, please review these slides. And we continue with next week with wireless local area networks. Okay, so again, no lab tomorrow. We will post homework questions a few days before the lecture. So hopefully we can have it on Monday for you to do the homework to prepare for the next lecture. All right. Okay, so the lecture officially ends here. I will stay for another 5 minutes in case you have questions.